Hello General Maths students. In this video we're going to do a double angle observation problem. Now it's going to involve the use of trigonometric ratios. So none of the maths is new in this video, it's just the context for the question. So this example is going to involve a diagram that looks like this one here. Of course you've got a blank page at the moment, unless you've had a go at the diagram already. So you might want to pause the video at this stage and copy a diagram just like this, and then I'll fill in the missing information when you restart the video. Okay, so I'll have a go at putting some of this information in now. So we're told that this woman is at position A, and there's an angle of elevation to the top of a 260 metre high tower. So I can tell from the numbers in this question that position A is going to be here because this is an angle of elevation of 35 degrees. Now later on at position B that's going to become 52 degrees, which is obviously closer, well they say that it's closer to the tower, and also the fact that it's a greater angle means that she must be closer to the tower. So the 260 metre high tower, that's going to go on this side of the triangle over here. And we're assuming that this is a well-built tower that's perpendicular to the ground, so there's a right angle in that corner. So then position B, she walks from A to B, and it's 52 degrees of angle of elevation there. So this problem is going to involve calculating the distance from A all the way to the bottom of the tower. I'll put B in there, and from B all the way to the end of the tower, and then finding this difference here to get that. That's what we want, is the distance between the two, which I'll call D. So we want this along here, that distance. Okay, so we're going to need three separate calculations here. Only two of them are trigonometric. The last one's just going to be some subtraction. Okay, so the first thing we want to do, we want to find this distance here, but we're going to have to find the distance from A all the way to the base of the tower. So think of this triangle, this big one that I've just outlined very poorly. I'll do it a little bit better. So imagine this right angle triangle, the biggest one we can see. How would you find the distance all the way from A to the bottom of the tower? I'll just call that x1 for now. So we've got the opposite and the adjacent sides. This is going to involve tangent. So the tangent of 35 degrees is equal to opposite over adjacent. 260 is the opposite side over x1. So remember, when the number's on top, it goes on top on the other side. So that's our calculation. So if you put that into the calculator, we should get 371.3 meters. Okay, now we want to find the distance from B to the base of the tower. I'll use a different color for this one. So that's going to involve this triangle here and finding this distance along the bottom, x2. Okay, very similar calculation because we've still got the opposite and the adjacent sides, just with a different angle of elevation. This time it's tan of 52 degrees. That's the only thing that's really different in this calculation. So when we do that one on the calculator, we get 203.1. Okay, so the difference between these two, x1 and x2, is that distance there. So that means that our distance, I'll make it red now, that one there, D equals 371.3 minus 203.1. And so we get a grand total of 168.2 meters. So as usual, go ahead and check the description of the video for the questions that you should try. There'll be a bunch of double angle type problems like this that almost always will involve 2 or maybe 3 calculations like this. But they're all just going to be Pythagoras theorem, sine, cos and tan. Nothing new from what you've seen, just a different context.